Welcome to Ask and Learn.
Hello there. So in this exercise we need to determine how many integers are between 50 and 100. So this gives us like an interval. But we need to determine how many integers are between 50 and 100 that are divisible by 7 and which are they. So how to do this kind of exercise? First you have an interval here, right? So the lower bound is going to be 50 and the upper bound is going to be 100, right? So the point is that 50 is equal to 7 times 7 plus 1, because 7 times 7 is equals to 49, and plus 1 you have the 50. Okay, and now we are going to see why I'm doing this. And for the 100 we have that is equals to 14 times 7 plus 2. Okay, so maybe you can see what is happening here. You can see that the number 8 times 7, it's going to be contained in this interval, because the upper bound is 14 times 7 plus 2. So 8 times 7 is less than 14 times 7 and is greater than 7 times 7 plus 1. That is the lower bound. And here I forgot the number 2. Okay, so this number is between this interval, and you can see that is a number that is divisible by 7. In a similar way, you can put here the number 9 and 10 until you reach here the 14. When you reach the 14, because here is the upper bound is 14 times 8 plus 2, this is going to be the last number, the last integer divisible by 7 that is contained in this interval. Okay, so the idea here is that you can, by writing these numbers in this way, you can see that between 7 and the 14 here, there are 7 possible integers that are going to be divisible by 7. Okay, so the number of integers that are divisible by 7 is going to be 14 minus 7, and in this case are 7 possibilities. Now, which are they? So let's remember that 50, which is the lower bound, okay, so 50 is equals to 7 times 7 plus 1, and over here we have the 100 that is equals to 14 times 7 plus 2. So which number is between these numbers? Well, let's start with 8 times 7, that is equal to 56. Then we have 9 times 7, this is equals to 63. Then we have 10 times 7, and this is equals to 70. Then we have 11 times 7, this is equals to 77. Here we have 12 times 7, and this is equals to 91. 84, sorry. And then here we have the 13 times 7, this is equals to 91, and last is 14 times 7, that is equals to 98. And here you have all the numbers, and you can see that are between 50 and 100 here, and are divisible by 7. So that's why you need to first write the lower and the upper bound like multiples, like multiplications with the number that you are dividing to, that you want to know if it is divisible or not. Another way to do this kind of exercise is considering the floor function. And basically you can define the lower like the lower bound by taking 50 divided 7 and the floor function of this number, and this is going to be equals to 7. This 7 is the 7 that appear in this part. Okay, or also you can consider is just the division without considering the rest. And here you're going to take 100 divided by 7 and the floor function that is equals to 14. In computational terms, this floor function can also be considered like the integer division that you can use in some softwares like Python or C or other programming languages. Okay, so the idea is that you first take the floor function of the lower bound divided by the number that you want to check how many integers are divisible by that number. In this case, is 7. And you take the floor function for the lower bound and for the upper bound, and then you subtract these two numbers. So 14 minus 7, that is 7, and that is the number of the numbers of integers that are divisible by 7 on that interval. And here you can check it, right? So we have here, you can see that here we have the 7 choices, the 7 numbers. Okay, so great. Now we need to repeat the procedure because now we need to determine how many integers are on the interval 15 and 100, but now that are divisible by 11, and which are they, of course. So in this case, we're going to repeat the same thing, but now I'm going to consider the floor function. So 50 divided by 11, the floor function of this is going to be equals to 4. Or in the way that I wrote previously, 50 is equals to 4 times 11 plus 6. And here with 100 divided 11, this is equals to 9, because 100 is equals to 9 times 11 plus 1. Okay, so you can see here that from 4 to 9, there are 5 possible integer numbers. Okay, and that's the same. So the number of integers divisible by 11 are 9 minus 4, and that is equals to 5. So there are 5 possible integers that are divisible by 11 on this interval. Which are they? Where you can see that we start from 4 until we reach 9. So the first number is going to be 4 times, sorry, it's going to be one more. I mean, we cannot, it cannot be 4 times 11 because this is 44 and is outside of the interval. So we start from 5. 5 times 11 is equals to 55. 6 times 11 is equals to 66. 7 times 11 is 77. 8 times 11 is equals to 88. And 9 times 11 is equals to 99. And these are the 5 choices. Now we need to determine which of them are divisible. So between 50 and 100, which of them are divisible by 7 and 11 at the same time. So you can do this when you have here the and. I mean, you need to divide to 7 and to 11. That means that those numbers, those integer numbers, should be divisible by 77. You need to multiply 7 by the other number, in this case, so 77. So 50 is not divisible by 77, so this is equals to 0. And here you have 100 divided by 77, and this is equals to 1. Okay, so you can see that between 150 there is only one number that is divisible by 77, and you can observe clearly that the only one is 77. Another way to do this is check the sets of the one that is divisible by 7 and the one that is divisible by 11, and you take the intersection. But the intersection, the only number that is contained in both sets is the 77. Here and in this set, you can see that the only element contained in both sets is the 77. Okay, so you can take either the intersection or check if which numbers are divided by the multiplication of those two.